Hi, my dear students in grade 6. This is our mathematics exam review lecture. In this lecture, we are going to discuss some of the important rules that we have studied in our lessons for semester 2 exam. So please concentrate and be ready. Topics covered in this exam for semester 2. Fractions 1. In this lesson, we have studied the reducible and non-reducible fractions, decimal fractions, and decimal numbers. Perpendicular bisector of a segment. We have studied how we can draw a perpendicular bisector of a segment. If we have a segment, how can we draw its perpendicular bisector? The steps for doing that. The angles. In this, we have revised together from last year the definition of the angle, how we measure an angle, how we draw an angle, then how we know that two angles or a pair of angles are adjacent or they are vertically opposite, how we draw the bisector of a given angle, what are the conditions for a pair of angles to be complementary and for a pair of angles to be supplementary. Now we are going to start with our lecture. Fractions, the lesson which is fractions. We've studied about equivalent fractions. If we have a fraction, we can get an equivalent fraction to it by multiplying this fraction or dividing this fraction, both numerator and denominator, by the same number. For example, if we have the fraction 3/7, how can we get an equivalent fraction to it? We can multiply the numerator by 2 and the denominator by 2. We get 6/14. These two fractions are called equivalent fractions. Suppose we have 10/6. We can get equivalent fractions by an equivalent fraction by dividing both terms by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. So 10/6 and 5/3 are equivalent fractions. Now, how can we reduce, or what do we mean by reducing or simplifying a fraction? To reduce or simplify a fraction is to make the fraction smaller. To reduce a fraction, we divide all the fraction, both the numerator and denominator, by the same number. This number is a common factor between the numerator and denominator to get an irreducible fraction. This irreducible fraction cannot be reduced anymore. This number should be a common factor between the numerator and denominator. Suppose we have the fraction, for example, 6/9. Both terms of the fraction, the numerator and denominator, 6 and 9, have a common factor which is 3. So we can reduce up by 3, down by 3. 6 divided by 3 is 2 and 9 divided by 3 is 3. 2/3 is an irreducible fraction. We cannot reduce it anymore. We have two methods to simplify or reduce a fraction. The first method is the method of successive division. How can we perform this method? In this method, we should use the criteria of divisibility by 2, by 3, by 4, by 5, by 6, by 9, and by 10. We try to divide the fraction, both terms, the numerator and denominator, starting from 2. If we can reduce or divide by 2, we divide. If we can't, we go to the successive of 2, which is a 3, until the result fraction is irreducible. Suppose we have here the fraction which is 18/12. Both terms can be divided by 2, so we divide up by 2, down by 2. 18 divided by 2 is 9 and 12 divided by 2 is 6. Now 9/6 cannot be divided by 2 anymore because 9 is not even, so we divide by 3 because 9 is a multiple of 3 and 6 is a multiple of 3. 9 divided by 3 is 3, 6 divided by 3 is 2, so 3/2 is an irreducible fraction. This is called the method of successive division. The second method, which is the method of GCD, we find the GCD of both the numerator and denominator by prime factorization. Then we divide the fraction by this GCD. Now, It's very important to remember that any fraction that has a numerator 1 is called an irreducible fraction. And if in a fraction the numerator and denominator are successive after each other, like 15 and 16, 4 and 5, their GCD is 1 and this fraction will be irreducible. For example, if we have 15 over 16 is irreducible, 21 over 20 is irreducible, and here if we have the fraction 1 over 10 is irreducible because the numerator is 1, 1 over 20 is irreducible because the numerator is 1, 1 over 17 is irreducible because the numerator is 1. Now, what are decimal fractions? Decimal fractions are those fractions that has a denominator 10 or 100 or 1000 or 10,000. For example, if we have the fraction 6 over 10, because the denominator is 10, it is a decimal fraction. If we have the fraction 17 over 1000, because the denominator is 1000, it's called a decimal fraction. If we have a decimal number in which we have a point and we want to change it into a decimal fraction, we have to follow steps. First of all, for example, if we have the decimal fraction, the decimal number which is 25.9, I want to change it to a decimal or write it as a decimal fraction. The first step, we should write the line of a fraction. To know the denominator, we count the number of digits in the decimal part. How many digits do we have in the decimal part? We have 1, so in the denominator we write 10. To know the numerator, we write all the number as it is without the point, 259. Now, if we have a decimal fraction and we want to change it to a decimal number, also we have here to follow steps. For example, if we have the fraction which is 128 over 100. This is a decimal fraction because the denominator is 100. We want to change it to a decimal number. The first step, we should write the numerator as it is, 128. Now we look at the denominator. How many zeros do we have? We have 2 zeros. So we put our finger to the right and we move it to the left 2 digits. 1, 2. Here we put the point, so it is 1.28. For example, if we have 9 over 1000, we should change it to a decimal number. We write the numerator as it is. We put our finger to the right. We move it to the left 3 digits. 1. We don't have any more digits. We should add 1, 2 zeros. So 1, 2, 3.0.009. This is how we change from a decimal number to a decimal fraction and from a decimal fraction to a decimal number. There are some fractions that are not decimals, but we can change them into decimal fractions. For example, any fraction having a denominator 2 can be changed into 10. How? We multiply it by 5. In a fraction, if we multiply the denominator, we should multiply the numerator. So we multiply the numerator by 5, then we get a decimal fraction. If the denominator is 4, 4 is changed into 100 by multiplying by 25. Denominator 5 is changed into 10. We multiply by 2 up and down. Denominator 8, we multiply by 125, we get 1000. Denominator 20, we multiply by 5, we get 100. Denominator 25, we multiply by 4, we get 100. Denominator 50, we multiply by 2, we get 100. Denominator 125, you multiply by 8, we get 1000. For example, if I have the fraction which is 11 over 2, this is not decimal, but we can change it into a decimal fraction. 2 is changed into 10. How? We multiply 2 by 5, so 2 times 5 becomes 10. Because we multiply the denominator by 5, we should multiply the numerator by 5, because in a fraction, everything we do for the denominator, we do it for the numerator and vice versa. So 11 times 5 is 55, so we get the decimal fraction 55 over 10. Suppose I give you the fraction which is 8 over 3. Can we change this fraction into a decimal fraction? We can never change this fraction into a decimal fraction because 3 is never changed into 10 or 100 or 1000. So here we write this fraction is unchangeable. It's impossible to change it to a decimal fraction. In our lesson, which is the perpendicular bisector of a segment, we should know the definition of the perpendicular bisector of a segment. What is the perpendicular bisector of a segment? It is a line perpendicular to the segment at its midpoint. So if we have a segment, the segment has a known length. Suppose we have a segment AB which has the length of 4 centimeters. I want to draw its perpendicular bisector. With a long ruler, I measure AB, it's 4. Then I should find the midpoint of AB because the perpendicular bisector of a segment is a line perpendicular to the segment at its midpoint. So first of all, we should find the midpoint of a segment. Suppose here will be the midpoint of the segment. We make a star. The distance from A to the midpoint is equal to the distance from the midpoint to the B. Now, using a set square, we put the set square on AB and we draw a perpendicular line to AB. Then this line, which is, for example, D, is perpendicular bisector of AB. So the steps to draw a perpendicular bisector of a segment, we should first know the measure of the segment. After knowing the measure of the segment, we find the midpoint of this segment by dividing the measure of the segment by 2 using a long ruler. We draw a line perpendicular to the segment at its midpoint using a set square. It's very important to know which rulers do we use. Now, there is a very important rule in the perpendicular bisector of a segment. Any point belonging to the perpendicular bisector of a segment is equidistant from the 2 extremities of the segment. What does this mean? After drawing D, the perpendicular bisector of AB, suppose that M is any point on the perpendicular bisector D. So M belongs to D. What can we say about MA and MB? Because M belongs to the perpendicular bisector to G, to AB, it will be equidistant from the extremities. It will be at the same distance from A and B. Then MA will be equal to MB. What do we mean by equidistant? Equidistant means MA is equal to MB. The distance between M and A is equal to the distance between M and B. Angles. First, we should know that to draw an angle or to measure an angle, we always use a ruler, which is the protractor. So the protractor is used to draw or measure an angle. When we talk about one angle, we have 5 kinds of angles. The null angle or the zero angle, the angle which measure is equal to 0 degrees. The acute angle, the measure of this angle is greater than 0 degrees and less than 90 degrees. Suppose that we have an angle which is 60 degrees, it's acute. 30 degrees, it's acute. 40 degrees, it's acute. 85 degrees, it's acute, etc. So it should be less than 90 degrees. Any angle having a measure equal to 90 degrees will be a right angle. Number 4, an obtuse angle. The measure of this angle is greater than 90 degrees and less than 180 degrees. For example, if I give you the measure of the angle is 110 degrees, so it is obtuse. The measure of the angle is 125 degrees, so it is obtuse. The straight angle, the measure of this angle is equal to 180 degrees and it will be forming a straight line, so this is the straight angle. Now, if we have an angle, how can we draw the bisector of an angle, or what do we mean by the bisector of an angle? The bisector of an angle is a line, so we should draw a line. This line divides the angle into 2 equal angles. To draw the bisector of an angle, so we divide the measure by 2 and we draw always the bisector of an angle using the ruler, which is the protractor. If we are talking about a pair of angles or 2 angles, These pair of angles might be adjacent angles. What do we mean by adjacent angles? Two angles are adjacent if they have the same vertex, if they have a common side, if they are situated at both sides of their common side. Suppose I have an angle OAB and I have another angle which is ABC or BAC. These two angles, which are OAB and BAC, we call them adjacent angles. Why do we call them adjacent angles? We call them adjacent angles first. The vertex of this angle is A and the vertex of this angle is A, so they have the same vertex. They have a common side. Here the sides are AO and AB. Here we have AB and AC. We can see that AB is a common side. It is in the first angle and also in the second angle. The third condition, they are situated at both sides of their common side. We have an angle above the common side and an angle under the common side. So these two angles will be adjacent angles. Now, how can we know the second position, which is a pair or two angles are vertically opposite angles? So two angles are said to be vertically opposite if they have the same vertex. The sides of one are the continuation of the other. Suppose I have an angle, this angle, which is XOY. This is the angle XOY. So here we have an angle XOY. Simply, if we elongate the side XO of the first angle and we elongate the side YO of the second angle, we will get a new angle. It's drawn in green. Suppose I call this angle ZOT. This angle, which is XOY and ZOT, they are called vertically opposite angles. Another two vertically opposite angles are the angles which are XOZ is vertically opposite with YOT. Any two vertically opposite angles are equal. Hope you enjoy our math lecture for semester 2. Please revise it well, and these rules are very important. All the best in your semester 2 exams.